Welcome back, guys. Today we have a high yield lab techniques question for the MCAT, and our question today gives us a mixture of compounds A, B, and C. And we are analyzing it using reverse phase high performance liquid chromatography, or HPLC. And our question today is asking us, based on the structures of compounds A, B, and C shown below, which compound corresponds to the rightmost or last eluting peak on this graph down here. Now, this is super high yield. You 100% need to know this. HPLC, super high yield, you need to know the difference between reverse phase and normal phase HPLC. So let's break it down. So I use this analogy, right, for this type of question. So I have my hand right here, and that's going to be the stationary phase, right? So we're doing chromatography here. So even though it's HPLC, it's kind of the same situation. You can use this analogy to get the right answer. You have your hand right here. This is the stationary phase. It's not moving, right? And then you have a mobile phase. And I like to think of this as some sort of like river of water or some stream that's running past the stationary phase. Now, the mobile phase, right, has your molecules. So A, B, and C, right, that is in the mobile phase that we're going to put into this stream of water, right, in our analogy, and it's going to run past this stationary phase, and we're trying to separate molecules A, B, and C, or whatever molecules they're giving you, by seeing how long they're going to stick to this stationary phase, right? So you load up this river with molecules A, B, and C, they start running past this stationary phase, okay? Now, based on how attracted these molecules are to the stationary phase, that's going to determine how long they stick. Now, how do you actually get the right answer based on this graph? So what this graph is saying is, if you stick to this stationary phase, right? So this river comes by, let's say you are a molecule that we're trying to separate and you stick for a very long time to the stationary phase, that means it's going to take a long time for you to get detected. So you get detected once you stop being attracted to the stationary phase and you pass right on by. This river just floats right on by. So if you're not very attracted, you pass on by the stationary phase and you get detected, right? So if you aren't very attracted to the stationary phase, that would represent this peak. And then if you're a little bit more attracted, right, maybe you stick for a little bit, but then you keep on going by and you get detected. And then this red line right here is the one we are trying to find, the one that is the rightmost or last eluting peak. You might see this written as like the highest or longest retention time, right? It sticks to the stationary phase the longest. So again, you have your molecules, A, B, and C, they go by, right? Now, how do you actually get the answer right? Well, you need to pay attention to this word right here, reverse phase. So this can either be reverse phase or normal phase. I think reverse phase is higher yield. And so reverse phase and normal phase has everything to do with, is this stationary phase polar or non-polar, okay? Now, in normal phase, this stationary phase is polar, right? In reverse phase, which I mentioned is a little bit higher yield, reverse phase means this stationary phase is non-polar, right? So it's going to attract non-polar things. And so things that are non-polar in our mobile phase, flowing on by, are going to stick to it for a very long time. So out of our molecules, A, B, and C, right, we look at A, it's got these carboxylic acids, right? This is pretty polar, so that is not really gonna stick to my stationary phase because it's very polar. So it's gonna go by, right? It's not gonna really wanna stick there. It's gonna get detected pretty early, right? If we look at C, right, a little bit less polar than A, but it still has this nitrogen, right? We're gonna get some dipole interactions there. It can also do hydrogen bonding, right? So more polar, right? It's still gonna stick maybe for a little bit longer, but it's gonna, head on by. We're gonna detect that. Now B, this is just a, hydrocarbon type situation, just hydrogens and carbons. It's very non-polar. There's no charge, there's no carboxylic acid, nothing like that. So it's gonna be very non-polar. So what happens? It goes by. This is going to stick, so right, B is pretty non-polar. It's going to stick to this non-polar stationary phase. It's going to hang out there for a while, and then eventually it will fall off and we'll detect it, but after a long time has gone by, right? So in this reverse phase HPLC, this right here is going to represent our highest retention time, right, for molecule B. And so our answer is molecule B here. Super important that you know the difference between reverse phase and normal phase HPLC.